This is the equation we now have for the magnetic field due to a long straight wire. You can see that if the wire is coming straight out of the page, then the magnetic field is going in circular patterns around the wire. It is proportional to the current going through the wire, and you can see that it is inversely proportional to the distance away from the wire. Now that we know the field due to one long straight wire, we can use that to find the force between two parallel current-carrying wires. So if the field due to wire A is mu naught IA, which is the current in A, over 2 pi d, then the force on wire B will be given by ILB, which is the current in B now times the length of the segment of B times that magnetic field caused by wire A. So substituting that equation for BA into the force equation, we end up with the force being mu naught times the length L times current in A times current in B over 2 pi times the distance between them. And of course, by the same reasoning, the force on wire A, because of the field created by wire B, is going to be exactly the same magnitude. Now let's look at how we work out the direction of that force. In working out the direction, we start by thinking about the field created by the current in wire A, which is on the left. We use the right-hand grip rule with our thumb pointing in the direction of the current to find the field at the position of wire B is pointing downwards, as shown by that green arrow. Then we can use the right-hand push rule with our fingers pointing downwards and our thumb in the direction of the current in wire B, and then we get the force pointing towards wire A. Now we can do the reverse and look at the field created by wire B. So if our thumb is pointing in the same direction here and we curl our fingers up, then we find that at the position of wire A, the magnetic field is pointing upwards. Then we use our right-hand rule with thumb pointing in the direction of current A, field, which is our fingers pointing upwards, and again our palm pushes towards wire B. So you can see that these are equal and opposite forces, which it should be because they are in fact an action-reaction pair. Now you can work through the same reasoning if the current in B was the reverse direction. So you should find that if the currents are flowing in opposite directions, there is now a repulsive force between those two wires.